Okay, Emily, let's check this out. You've got the squeeze theorem that you're going to use. We know that f of x is this function, and because cosine or sine have the trait that it is always between or equal to -1 and 1, so the cosine of anything or sine of anything right is always between -1 and 1. That means that this whole function is at its smallest when this is -1 and we have -x squared, and this whole function is at its biggest when this thing is +1 and then it's +1 times x squared, okay? And that's why we've got this, that's why you can say that h of x is less than or equal to f of x is less than or equal to g of x. Okay, and I'm sure you already know that. But, you know, typically you see the sandwich or the squeeze theorem or sandwich theorem, I think they're the same thing. You see it in this form, right? Use a squeeze theorem to find this limit where it's x squared cosine of something. It's either sine or cosine, it's always that. So if I'm going to do this one, I tell my students to, that, you know, you have to say, because, in this case, cosine of theta is between -1 and 1, we know that, if we call this f of x, right, we can say that -x squared is less than or equal to f of x is less than or equal to x squared, right? We know that that's the case. So because this, we know this is true. And since the limit as x approaches 0 for, right, h of x, -x squared, equals the limit as x approaches 0 for x squared equals 0. And then I always conclude then by the sandwich theorem or squeeze theorem. The limit as x approaches 0 for f of x is 0. Okay, now when I teach it, I don't start here. I say, since we know this and this is true, then by the squeeze theorem, that is the value of the limit, right? And that is pretty much what you had to do up here. I'm not certain that you have to start with that. I believe we can start here. So when I teach the class, I say, since this is true and that's true, then by the squeeze theorem, that's the limit, okay? Hopefully you could see it. I was trying to hold my phone while I was doing that, but hopefully that makes sense.